students, in this video we are going to be discuss definition of reflection, types of reflecting surfaces, and the final one is laws of reflection. So before going to be watch my video, please subscribe my channel and share to your friends. Had you ever reflected sunlight by using the plane mirror to flash a message to your friend? Yes, these things which you are going to be do during the class hours. So coming to the reflection, when the light is fall on the reflecting surface, it will bounce back into the same medium. This phenomena we are calling as the reflection. Coming to the definition of the reflection, the phenomena of bouncing back of light into the same medium after striking the reflecting surface. This is called reflection. Is it clear, children? Once again I am repeating the definition. The phenomena of bouncing back of light into the same medium after striking the reflecting surface. This is called reflection. So coming to the reflection, we have two types of reflection based on the reflecting surfaces. So if the reflecting surface is the plane surface or smooth surface, you will get the regular reflection. Why? Because it have the definite reflecting rays, so we are calling that as the regular reflection. Coming to the irregular reflection or diffuse reflection, when the light is fall on the irregular surface, then the light will be diffused or scattered in all the direction. This phenomenon you are considering as the irregular reflection. So coming to the regular reflection, the phenomena of reflection of light in a definite direction from a smooth polished surface is known as the regular reflection. So in this diagram, when the light is a beam of light is falling on the smooth regular surface, after falling the light, you will get the reflecting light in a definite manner. So this kind of reflection we are considering as the definite reflection or regular reflection. Coming to the irregular reflection, when the light is fall on the irregular surface, the light is scattered in all direction. It is not in the regular manner. So this kind of reflection we are considering as the irregular reflection. Coming to the irregular reflection definition, the phenomena of reflection of light in all direction, like scattering from the irregular surface, is called irregular reflection. Of reflecting surface, we have broadly classified reflecting surface into two types. One is plane reflecting surface, another one is the spherical reflecting surface. Coming to the plane reflecting surface, here I have drawn the plane reflecting surface diagram. So the reflecting surface, this is the reflecting surface, and coming to this side coated with the paint. Is it clear, children? So when the light is fall on the reflecting surface, it will be reflect. Coming to the spherical reflecting surfaces, these two spherical reflecting surfaces or spherical mirrors are the part of the sphere. So in this again we have classified into two types. One is concave mirror and the second one is convex mirror. Coming to the concave mirror, if the reflecting surface is inward or the silvered part is inside, such kind of mirror we are considering as the concave mirror. Coming to the convex mirror, the reflecting surface will be outwarded. That is called convex mirror. In case of a convex mirror, the silvered one is the outside. Is it clear, children? So in case of the concave mirror, cave is nothing but in Telugu guha. So we need to enter into the cave. So it will be inverted. Is it clear, children? In case of a concave mirror, the bulged surface will be inverted. In case of the convex surface, the bulged surface will be outward. Is it clear, children? So in the final conclusion between the concave mirror and convex mirror is, whenever you touch the concave mirror, the bulged portion of the surface will be inverted. Coming to the convex surface, the bulged portion of the surface will be outwarded, or the reflecting surface will be outwarded in case of the convex mirror, and the reflecting portion will be inverted for the concave mirror. Is it clear, children? This is the differences between concave mirror and convex mirror. In the upcoming video, in detail, I am going to be explaining the differences between concave mirror and convex mirror. Let us consider the light is falling on the plane reflecting surface as shown you. When the light is fall on the plane reflecting surface, it will be reflected, the light ray will be reflected into the same medium. That is called reflection. When the light ray is falling on the reflecting surface, it will be entered into the same medium. This phenomena of entering of light after striking the reflecting surface called reflection. So coming to the laws of reflection, the incident ray, reflected ray and normal will lies on the same plane. And coming to the second law of reflection, the angle of incidence is equal to angle of reflection. So before going to explain this concept, initially I need to explain some terminology which included in the reflection concept. Coming to the incident ray is nothing but the ray which is going to be strike the reflecting surface. Here AO, the ray is going to be strike the reflecting surface. So this ray we are calling as the incident ray. Coming to the reflected ray, the ray which sent back after striking the reflecting surface, the ray which sent back, that is called reflecting ray or reflected ray. Is it clear, children? In the diagram, OB is called reflected ray. So coming to the normal is nothing but it is the imaginary line. Is it clear, children? We won't get the normal we are unable to see the normal by looking the plane surface. It is the imaginary concept. Is it clear, children? So normal is the perpendicular line which is drawn at the point of incidence, that is called normal. Is it clear? Normal is nothing but it is a perpendicular line which drawn on the point of incidence, that is called normal. Coming to the angle of incidence, the angle between the incident ray and the normal is called angle of incidence. This angle we are considering as angle of incidence or incident angle. Coming to the angle of reflection, the angle between the normal and the reflected ray, that is called angle of reflection. This angle we are considering as the angle of reflection. Coming to the point of incidence, the point at which the incident ray meet the reflecting surface, that is called point of incidence. Nothing but point point of incidence is nothing but the incident ray where it is going to be meet the reflecting surface. That point we are considering as a point of incidence. In the diagram, I represented point of incidence by using the letter O. So in the diagram, AO is representing for the incident ray, OB is representing for the reflected ray, ON is representing for the normal. Coming to the angle of incidence, angle AON. Here, angle AON we are considering as the angle of incidence. Angle NOB we are considering as the angle of reflection, which I represented by R. Clear, children? Coming to the point of incidence, O. And some terminology also there. The terminology is the angle between the incident ray and the reflecting surface, that is called glancing angle of incidence. Glancing angle of incidence. It is denoted by alpha suffix I. Coming to the here, the angle between the reflected ray, and the reflecting surface, that is called glancing angle of reflection, that is represented with alpha Z. However, glancing angle of incidence is equal to glancing angle of reflection, alpha R. Glancing angle of reflection is denoted by alpha suffix R. However, the glancing angle of incidence is equal to glancing angle of reflection. Why? Because this angle and this angle both are same. By means of that, you will get these two angles also same. So in case of the reflection, we are going to be discuss the laws of reflection. So coming to the laws of reflection, the incident ray, reflected ray and the normal will lies on the same plane. See, for suppose here I had taken the point of incidence. Why? Because the incident ray is striking the surface at that point only. Because of that reason only I took the point of incidence there. Is it clear, children? For suppose if the point of incidence occurred at this point, nothing but on O dash. So here you will get the incident ray, reflected ray and normal. From the first law of reflection, nothing but from this statement, it is clear that normal is a imaginary concept for the reflecting surface which could be existed anywhere on the plane. Is it clear, children? Normal should be existed anywhere on the plane. Is it clear? From the first law of reflection, it is clear that the normal will be existed anywhere on the plane. Why? Because in the diagram I took the normal here. Why? Because the incident ray is falling on the surface at this point only. Is it clear? For suppose the incident ray is met at the point O dash, then you will get the normal at O dash. For suppose if at all you are getting the incident ray at point X, there also you are going to be get the normal. So the normal is the imaginary concept which can be obtained by drawing the perpendicular line to the plane surface. Coming to the spherical surface, this is the imaginary, this is different concept. Is it clear, children? So from the first law of reflection, it is clear that the normal will be existed anywhere on the plane. Coming to the second law of reflection, the angle of incidence will be is equal to the angle of reflection. Is it clear, children? Angle of incidence is equal to the angle of reflection. Now my question is, does the laws of reflections are valid for the spherical surfaces? Will you guess the answer? Yes, the laws of reflections are valid for the spherical surfaces also. Is it clear, children? Whatever the laws of reflections are there, those laws of reflections are valid for both plane regular surfaces and the spherical regular surfaces. Is it clear, children? Once again I am repeating the laws of reflection. The first law of reflection is state that the incident ray, reflected ray and the normal will lies on the same point. Coming to the second law of reflection, the incident ray, reflected ray and the angle of incidence is equal to the angle of reflection.